All right, guys, there we shall have a continuation on our exponential equations. Remember, we were dealing with our exponential equations and we referred to the first part of our equations. Let's say we are just given the same exponent, and on that particular question, you can be able to factorize the given questions because you are having the same exponent, and it's possible for you to do the factorization or just add. What I'm trying to say is that we had a condition of this nature. Let's say we are given 2 to the exponent of x plus 2 to the exponent of x. It is because what we have here, what we are given is the same. We have got the same exponent. So we can be able to add this part to say this is a 1 and this is a 1. So you can just add, or you can factor out the 2 to the exponent of x, which is common. We remain with the 1, and here we also remain with the 1, which is equal to 8. All right. But if you are to check now, what we are having on these exponents are totally different from the scenario that we had in our previous case like this. So how do we solve such? All right. Considering our first equation, which is x to the exponent of 1 over 2 minus 5x to the exponent of 1 over 4 plus 6 is equal to 0, like that. So for the first part, I want you to consider watching that video so that you'll be able to understand the basics that we had on our introduction, because this is a continuation. So I said that in our last or previous exponents, you're just solving direct, right? There's nothing that is complicated there. But in this situation that we are given here, what you need is to make sure that you are going to write one of these in terms of the other exponent. There is an exponent of 1 over 4. There is an exponent of 1 over 2. So how are you going to tell that you're going to write this exponent in terms of this, or you're going to write this in terms of this? All right. Always you're going to check for the numbers that you're given. We have got 1 over 4, which is the exponent. So you check for the one that has got the smaller exponent, so that you write the one with the bigger exponent in terms of the smaller one. All right, let's check our exponents here so that we become practical. This is 1 over 4. As a decimal, it's going to be 0.25. All right, then we move on to 1 over 2. That 1 over 2 as a decimal, it's 0.5. So I want you to compare these two. If you compare this 0.5 and 0.25, you will see that this one is the smaller one. 0.25 is smaller than 0.5. 0.5 is bigger than this. All right, meaning to say 1 over 2 is bigger than 1 over 4. This 1 over 2, this one, is bigger than this. All right, so we are going to write the bigger one in terms of the smaller, one. What am I trying to say? We are going to write this x to the exponent of half as x to the exponent of 1 over 4. But we are supposed to obtain the same x to the exponent of a half. So I want us to get back to our laws. Remember, from our laws of exponents, we explained this. If we are given a to the exponent of m being raised to the exponent of n, we know that we can multiply our exponents together, m and n. So we need a number here that we're going to use, so that if we multiply by that number, we are going to obtain the same 1 over 2. All right, we need a number here because we're going to multiply to get this 1 over 2. So we need a number like, if we multiply 1 over 4 times x, we are going to obtain a 1 over 2. This one, we are not supposed to change the meaning of the question. The question there is x to the exponent of a half. So you're not supposed to change the meaning. So if you know the number here that I'm going to raise this to the exponent of 2 so that it gives me a 1 over 2, it's fine. But if you do not know, then you're going to use this concept to say, I have got 1 over 4 that I'm going to multiply to a certain number so that I obtain 1 over 2. So what is this number that I'm supposed to have? So you just have to divide, since you're multiplying. So it's 1 over 2 divided to 1 over 4. 1 over 2, just divide to 1 over 4 like this. On your calculator, this will give you a 2. So that's the number that exactly we need in this case here, so that we obtain this 1 over 2. All right. So if you multiply properly, a 1 over 4 times a 2, you're going to get 1 over 2, which meaning to say on this part here, we haven't changed anything. But what we just want is right in terms of the smaller exponent. And as you can see, we are formulating a quadratic equation. The highest exponent is now a 2. All right. So the rest of the part is going to remain as it is like this. All right. So once you have this, we are now having a quadratic equation. This is a quadratic equation that you can solve direct, or you can introduce the K method. All right. So let me just start by the K method. Then we can try by all means to solve this one direct. We can introduce to say where we have this one. Remember, we are now having a common term, x to the exponent of 1 over 4. So we can let that to be equal to K. All right. Let K to be equal to x to the exponent of what? 1 over 4. So what does it mean? In place of this, we are supposed to substitute K in this case, but this is a squared. So that is going to be K squared. Minus 5 in place of this x to the exponent of 1 over 4, we substitute a K plus a 6 like that is equal to 0. So we have formed a normal quadratic equation that we are used to. Yes, this one is a quadratic equation if you check, but to work with this, most of us, we get confusion there. Say, how are you going to factorize? But we are just supposed to factorize direct, just like the way you understand this. All right. This one, we are much used to this one. All right. So you can factorize. Remember from our grade 10, we said if this here is being a 1, we can have 2 brackets direct by factorization. Just use your factorization. We can have a K here and another K, so that K times K is going to give us 1K squared, 1K squared. All right. Then we consider now on this part, positive 6. We've got a positive 6 here. What are the factors of this positive 6? All right, which is our constant. But they are supposed to give us what? A negative 5. So we need the product first of 2 numbers. We're supposed to work with the product of 2 numbers. The product of these 2 numbers should give us a negative 6. A positive 6, as you can see, it's a positive. So in order for us to get a positive, we can have 3 and 2, but we can't obtain something like a negative 5 there. So what do? We just put a negative and a negative. Remember, negative, if you multiply, it gives you a positive. And if you add this minus 3 plus minus 2, you're going to obtain a minus 5. So these are the numbers that we want that satisfies exactly what we are given here. So that's a negative 3 and a negative 2. From these, one of these must be equal to 0. So it means K must be equal to what? If okay, let's just write K minus 3 must be equal to 0, or the bracket of K minus 2 must be equal to 0. From there, we can solve for K. But this is not part of this is not our solution actually. So K will be equal to what? If we transpose negative 3 to that side, it becomes a positive. It was a negative. The moment it crosses the equal sign, it becomes a positive. So you have to be careful. All right, sorry for that. So you see that this will give you a 3, or on the other side, if you transpose this side, that was going to give you a 2. So from these solutions that we are having, remember, we introduced a condition where we said x to the exponent of 1 over 4 was equal to K. This was the introduction that we had. K is equal to this. So at the end, we are now supposed to find the exact value of x. All right. We are now supposed to find the exact value of x. So from this, we can simply take our K, which is the first solution. That is x to the exponent of 1 over 4 is equal to a 3. Or we move on to this other part, x to the exponent of 1 over 4, which is equal to 2 in that case. All right. So this is how you are supposed to have your solutions at the end. So remember, this is the part that we had in our previous case. That's why I was saying you're supposed to check that class because we had this part, and I said in order for you to solve when you're given an equation like this, you are supposed to find the reciprocal of this exponent, which is 1 over 4. The reciprocal of this, that is 4 over 1. We just have to interchange here. So 4 over 1 is same as 4. So you're going to raise everything to the exponent of 4 to remove this exponent of what? 1 over 4. So that's if you multiply here, you're going to get a 1. X to the exponent of 1 is equal to 3 to the exponent of 4, which will be 81. Or x will be equal to 2 to the exponent of 4, which is going to give us a 16. So these are the possible values that you're going to have. X, which is 81, and the other one, which is what? Which is a 16. So what we're supposed to do in actual sense is to prove our solutions to see that if they are actually part of our equation, if they satisfy this equation that we are given. So we're just going to do this. Remember, we've got two solutions, the one which is a 16 and the one which is an 8. So there we can just use our calculator direct to see that if these solutions do satisfy this. So the first one, 81. So that is 81 to the exponent of a half. So that is we're gonna have, all right, well, let's just put it direct. 81 to the exponent of a half, which is 1/2. We have to test this and see if it satisfies this. All right, then again, we've got times. 5x means times. You're going to multiply this, or you're going to just open a bracket, which is 81 again to the exponent of 1/4 here. So this is to the exponent of 1/4 like this. All right, then we move on to this plus a 6. Is it going to give us a 0? That is what we need. So this gives us a 0. We move on to the other one. It was a 16. All right, the other solution was a 16. So I'm just going to have 16 here. All right, in another solution, it was 16. So here we're just going to have our 16 like this. All right, again, it gives us a 0, as you can see. So that means our solutions, they are actually true. So you have to test your solutions. So this is the situation that you're going to do throughout. So you see that we are going to formulate quadratic equations at the end. That is what you're going to formulate. So if we check on number 2 on that condition, this is given as to the exponent of question 2, that is x to the exponent of 2/3 minus 7x to the exponent of 1/3 plus a 10 is equal to 0. So like I said, you can even solve direct without even introducing the K method. But for this case of understanding, I'm just going to work with the K method. So if we check here, we 2/3 and 1/3, we'll see that 2/3 is the one that is bigger here. 2/3 as a decimal, it's 0.666 like that. Then 1/3 is 0.333 like that. So we are seeing that the 2/3 is the one that is bigger in terms of the decimal. So we said we write it in terms of the smaller one. So we are going to write this as x to the exponent of a third, which is the smaller one. But what are we going to use here so that we are going to obtain the same exponent 2/3? So as you can see, that's to the exponent of 2. If you multiply 1/3 times 2, you get 2/3. All right, minus 7x to the exponent of a third plus a 10. So like I said, this stage, you are not supposed to change the meaning of the question. So if you wanted to apply your factorization direct, you can apply it. If you want, you can use the K method. All right, since the coefficient of this term is 1, this is our common term, this one, x to the exponent of a third, x to the exponent of a third, we also have it here. And we have the product, I mean, going to have the product of two brackets, that is x to the exponent of a third, the one that is raised to the exponent of what? 1/2. So we're going to have another one here, x to the exponent of 1/3, just like k and k. Then now, how do you factorize? Remember, we said we focus on the constant, which is 10. What are the products in this case? We are looking for the what? For the products of 10. Two terms that you're going to multiply to get a positive 10. But if you add these numbers, you must get what? A -5, a -7. So by just having a negative on the sum of the numbers, it means these numbers should be negatives. All right, instead of us working with 5 and 2, we are going to have -5, -2. If we multiply -5 and -2, we get a positive 10. If we add these two terms, we get a -7. So that means we've got a -5 here and we've got a -2. So if you were to use the K method, it was simply one and the same thing, because on this part here, you're going to see that this equation, if you were going to use the K method, it was just going to be one and the same thing. At this stage, you are going to have this as what? You're going to have this given as, instead, you introduce K, let your K be equal to x to the exponent of a third. So that means here we've got x to the exponent of a third represented by K, but that is raised to the exponent of 2. So it's going to be K squared. All right. So this will be K squared minus 7K in this case. In place of this x to the exponent of a third is going to be 7K plus a 10 is equal to 0. So as we can see, it is simply one and the same thing. On your factorization, you're going to have one and the same thing. This is K squared, the coefficient there is 1, so you're going to have K and K here. Focus with 10, what gives us a -7? Still, you've got the same numbers, -5 and -2. So you're going to have -5, -2. So this is what you have from this. You saw for K here, K is going to give you a +5, or K is going to give you a +2. You take them now to the original simplification here that we introduced. But on this one, it gives us the solutions direct, because we are already having our solutions in terms of what? In terms of x. So if we equate this bracket to 0, it means we are going to transpose the -5 to the other side. It becomes a positive. X to the exponent of a third is equal to 5. Or we transpose -2 to the other side. So that means x to the exponent of 1/3 is equal to a +2. So if you were using the K method here, that is where you introduce now to say, after now this stage, you are now taking this K, x to the exponent of a third is equal to 5, or this K, x to the exponent of a third is equal to 2. So as you can see, we are now back to the same stage as you are at this stage here. Just one and the same thing. So with either way that you're using, you're going to introduce the K, or you can do the factorization direct by just looking. You can say, okay, this is the same quadratic equation that I'm used to. This is from our grade 10. So meaning to say we can apply that factorization. All right. Then from this, like I said, we are now left with a single term on the left-hand side and a single number on the right-hand side, which is also can be considered as a single term. That's where you think of removing this exponent here so that we remain with x. But I said you do not just remove this. You have to find the reciprocal, the inverse of that number, the inverse of what? 1/3. So 1/3, the reciprocal, just interchange, it's going to be 3/1. But 3/1 is same as what? Is same as 3. So we raise this to the exponent of 3, this also to the exponent of 3. We raise this to the exponent of 3, this also to the exponent of 3, to the exponent of what? The reciprocal, the inverse of what we are given there. So that means we are going to obtain x. Remember, a third times 3, that is going to give us 1. X to the exponent of 1 is equal to 5 to the exponent of 3, which will give us 125. Or x to the exponent of 1, if we multiply here a third and a 3, we're going to get a 1. Is going to give us 2 to the exponent of 3, which is 8. So these are the solutions that we are expecting to have. But before we conclude to say these are our solutions, we are supposed now to test this. If we bring these solutions into our equation, are we going to have a 0 there if our x is 125? So I want you to prove these numbers, 125 and 8. You're going to get a 0 in that case, meaning to say these solutions, they are true. So this is the same situation that I want you to do on number 3, on number 4, on number 5, and number 6, and so on and so on and so on. It's the same situation. But I want us to consider question 6 a little bit different. But if you have a challenge on these questions that you can see that I've indicated 3, 4, 5, because I see like it's a repetition there. But if you have a challenge, let me know on those questions so that we can work on them. But as for now, I'm just going to rush through to the question 6 there. On question 6, we are given just a little bit different, but it's the same thing. You will see that it's just one and the same thing. We are given there 5x. All right, so this is 5x plus 7 square root of x. minus 6 is equal to 0. So if we are to consider this, they are exponents there. They are exponents. All right, 5x is same as 5x to the exponent of 1. We know that. What about the square root of x? The square root of x means to the exponent of what? Of a half. So if we are to consider this, there is an exponent here, there's an exponent. Remember I said you have to write the bigger exponent in terms of the smaller one. Here we can compare and see that 1 is bigger than 1 over 2. 1 over 2 is a fraction, it's a decimal, 0.5. So 1 is bigger. So we have to write this one in terms of this x to the exponent of half. How is that possible to have x to the exponent of a half like this, but giving us this one? Which exponent are we supposed to use here? That's a 2. Half of a 2 is what? It's a 1. So we haven't changed anything. Our question is still the same. We still have our question there. Our question hasn't changed. We haven't changed anything. All we just is to write in terms of this. Once we can have it in terms of this, it means we are now having a normal quadratic equation that we are used to, where we can solve it direct, or we can introduce the k just like the previous case. Let k be equal to x to the exponent of a half. So that means here we are, and here we are going to introduce k. That means we've got 5 k raised to the exponent of 2. So that's 5k squared plus 7k in place of this is equivalent to k minus 6 is equal to 0. So there we are supposed to solve for k just like a normal equation. Is it by factorization? Is it by the quadratic formula? You solve this equation. All right. So as you can see that the coefficient here of k squared is no longer a 1. Yes, we can do that trial and error method. But for most cases, I've seen you guys having challenges on that. So I want to avoid that because this can give us a challenge. So let us just use our normal part. When this is no longer 1, just use the basic part where you multiply the first term. Take note, you multiply the first term to the last term. You find the product of these two. You multiply them together. 5k squared times negative 6. We get a negative 30k squared. Then you find the factors, which are the products, just like the previous case, of minus 30k squared. Take note, 2 terms that you multiply, you get this. But when you add, you are supposed to get this middle term as it is. You are supposed to obtain a positive k. That is a positive 7k. We are supposed to obtain this, the middle term. Do we have terms that we multiply to get negative 30? There are so many terms that we can multiply to get a negative 30. Take talk of 10, 10k, and a positive 3k. So in order for us to have a negative there, it means 1 must be negative. So it's either 10 is negative or 3 is a negative. There is 6k and 5k. If we multiply this, one of these being negative, we get a positive, we get a negative 30k, or it can be 6k and a negative 5. There are so many numbers that we can use, 15 and 2. But we cannot, guys, work with all these numbers because we need a condition that will give us a 7. So a 7 is mostly on this 10 and 3. That's where we can have this 7. But which part now? If we add these two, we get a negative 7k. If we add these two, remember I said the sum, which means we have to add. If we add these two, we get a positive 7k. So these are the terms that I want. So with these two terms, how do you solve? You substitute them back to the middle term. So it's going to be 5k squared in place of this middle term, this one. You substitute those terms now, which is 10k plus 10k and minus 3k. So as we can see, guys, we haven't changed anything because 10 minus 3, it gives us what? 7. We still have the 7k. But what we have just done here is that we have now 4 terms, and we understand by factorization that if we've got 4 terms like this, we can group them into 2 by grouping what is common between these 2 terms, 5k. So you're going to divide, factor out 5k by 5k. That will give us a k plus 10k divided by 5k, which is a 2. All right. On these last 2 terms, what is common? that is -3. We factor out -3 and -3. If we divide, it will give us a positive k. -6 here divided to -3, it will give us a positive 2. So remember the concept of your factorization. One of these brackets are, sorry, these two brackets are the same. So you're going to factor out the bracket of k plus 2. Then you remain here with 5k, and here you remain with -3. That will be another bracket there. So one of these brackets, remember, it must be equal to 0. So we have to solve there. K plus 2 must be equal to 0, or 5k minus 3 must be equal to 0. So k there is going to give us what? If we transpose a positive 2 to the other hand, it gives us a negative, sorry. That's gonna be a -2. Or this one is going to be a positive. It was a negative. Transpose it on the other hand, it becomes a positive on this side. So that's a +3. So you can divide by 5, so meaning to say k is simply going to be what? 3/5 if we divide by 5, all right? So these are the values of k, not x. So to be honest, guys, at this point, if you are actually stuck here, use the quadratic formula, solve for k there. What we just need are the values of k, all right? Use your quadratic formula, solve for k, obtain the k values. Then from this introduction that you introduced here, k is equal to x to the exponent of 1/2. So now we can introduce back our k, because we said k is what? X to the exponent of 1/2 must be equal to the k that we are obtaining here, which is -2, or the same, x to the exponent of 1/2 is equal to this 3/5. We are now back to the normal exponential equation of removing this exponent of 1/2 by finding its reciprocal. What is the reciprocal of 1/2? Is 2/1. So the exponent of 2/1, which is same as what? Which is the same as 2, to the exponent of 2, to the exponent of 2, everything to the exponent of 2. So this gives us x. If you multiply here, 1/2 of 2, that's 1, is equal to -2 squared. -2 times -2, that's a +4. Or x is going to be what? If we raise this to the exponent of 3 on to the exponent of 2 on your calculator, that is going to be 9/25. So these are the x values that we are obtaining. But like I said, everything has to be tested. Everything has to be tested on whatever that you are going to obtain. We have to test these solutions and see which one is the best. All right, so let us take our solutions here. This is 5x square root. All right, let me just bring the calculator and see. All right, so here we're gonna have to test and see which one is going to satisfy this solution. 5x, remember our x values that we got, our x values, sorry for that, it's 4 and 9/25. All right, so let's start with 4. I'm gonna substitute a 4 there. 5 times 4, that's 5 times 4 plus 7 square root of 4. All right, just move this aside, -6. This gives us a 28, not a 0. We are supposed to get a 0. There we are getting a 28. So it means if x is equal to 4, this is totally wrong. So x cannot be equal to 4. We move on to 9/25. Maybe it cannot be a solution again. It can be like that. So you have to test again. In place of this square root there, it's going to be 9/25. 9/25. All right, let's put here. In place of x, 9/25, 9/25, like this. So this will give us a 0, as you can see. This gives us what? A 0. So this is the exact solution that we want. So therefore, x is going to be 9/25. That's why I said you must test your solutions, all right? You must test your solution. So therefore, x is equal to 9/25. Okay, this one does not satisfy our equation. All right, so we are not going to have this as part of our solution. No. Okay, so let's see. Question number 7, it is one and the same thing. On question number 7, if you check there, it is just one and the same thing. But we're just gonna try to solve this one without the K method. Yes, you can use the K method, but I'm just gonna use direct method there. X minus x to the exponent of 1 over 2 minus 12 is equal to, so as you can see, this is just one and the same. Like I said, it's the same as what? To the exponent of a 1. So in terms of to the exponent of a half, it means we're going to have x to the exponent of a half to the exponent of 2 minus x to the exponent of a half minus 12 is equal to 0. So like I said, this one I'm just going to solve direct. I'm not going to introduce the K method, but you can use the K method. All right, 2 brackets, as we saw from our K method, x to the exponent of 1 over 2, which is the one that is common, x to the exponent of 1 over 2. Then we focus on the factors of what? Negative 12. Since this is a 1, you focus on this direct. All right, what are the products here of negative 12, or the factors of negative 12? But you add them, they must give you a negative 1. So there are so many numbers that you multiply to get a negative 12. Negative 6 and 2, 6 and negative 2, negative 12 and 1. So many numbers. But of all these, we need a part that when we add, we are going to get a negative 1. So that's negative 4 and 3. If you multiply this, you get a negative 12. If you add these two, you get a negative 1. So these are the 2 terms that I want, negative 4 and a positive 3. So one of these brackets must be equal to 0. X to the exponent of 1 over 2 minus 4 must be equal to 0, or x to the exponent of 1 over 2 plus 3 must be equal to 0. Transpose this. So that means x to the exponent of 1 over 2 is equal to a positive 4, or x to the exponent of 1 over 2 will be equal to what on the other side? This will be a negative 3. So there we are on the introduction of the reciprocal of the inverse of the exponent there, which is 1 over 2. We talked about this. We said the reciprocal of this is what? Is 2. So that's a 2 there, a 2 there. All right. So if you multiply 1 over 2 and 2, that will be a 1. So x to the exponent of 1 is equal to 4 to the exponent of 2, which is 16. 4 times 4. Or x is equal to minus 3 to the exponent of 2, which is going to give us a positive 9. But one of these solutions must satisfy our equation. If x is 16, are we going to obtain a 0 there? So let's test. If x is 16, are we going to have a 0 or not? That is, okay, let's start. X is 16. 16 to the exponent of a 1 minus 16 to the exponent of 1 over 2. All right, minus a 12 like this. This is going to give us a 0. This one, it satisfies our solution. That's when x is what? 1 over, when x is 16. What about if x is what? 9. If x is 9, we're just going to change where there was x and put 9. Where there's 16 here, just going to put a 9. So there, just going to put a 9. And also here a 9. Also a 9 there. So if you check, this is negative 6, not a 0. We are supposed to get a 0, not a negative 6. So this means that our x cannot be equal to what? Our x cannot be equal to 9. So therefore, our x is equal to what? Our x is equal to 16. That is the solution that I was expecting you guys to have at the end. So with this, you can also attempt different questions. If you check, there are so many questions here to consider. Maybe number 8, because we've got a negative exponent there. X to the exponent of negative 1 minus x to the exponent of negative 1 over 2. All right, this is equal to 20. So you're going to transpose 20 to this side. It becomes a negative like this, is equal to 0. So if you are to consider it's just one and the same thing, there it was a positive 1. If you consider, we still have the same numbers here, only that this is negative 1. Here it was a positive 1. Only that this one is now a negative 1, a negative half. So nothing has changed there, only this negative. So meaning to say we can write it in terms of x to the exponent of what? Minus 1 over 2. X to the exponent of minus 1 over 2. but raised to the exponent of what, so that we obtain this -1 raised to the exponent of 2, minus x to the exponent of 1 over 2 minus a 20 in this case is equal to 0. So you formed an equation which is a quadratic equation in that case. All right. So from this quadratic equation, you're going to solve for x. You can use the K method, or you can solve direct. All right. So solving direct, we have got 1 here. So that means we're going to just have a direct factorization there. X to the exponent of what? Minus a half. Now it's minus a half, not a half, not a positive. All right. Focus on this number, -20. What are the products of -20? If we add them, we must get a -1. So we are focusing on the factors which are the products of what? -20. We've got -5 and 4 there. We have got 5 and 4. This is where a 1, where we have the chances of getting a -1 on 5 and 4. But which one exactly are we going to take? All right, if we multiply these two numbers, it's true that we get a -20. Also here, if we multiply this, if it is a negative, we're going to get a -20. But which part, when we add, we're going to get a -1. So this is the one. If we add here, we are going to obtain a -1. So that means these are the numbers that I want. A -5 here and a +4 here. This is going to be equal to 0. So we've got two solutions that we got, two brackets. That means one of these must be equal to 0. Guys, like I explained, you transpose this, it goes to the other side. So that means you are just left with what? X to the exponent of what? Minus a half on this side, which is the same thing on this 4. You transpose it on the other hand, meaning to say it becomes a +4 on that side. All right. So this is what we are trying to say. Let's save it. So that means this is going to be a positive x to the exponent of -1 over 2 is equal to a +5, or x to the exponent of -1 over 2 is going to be -4. All right. Then the reciprocal. So the reciprocal part is not going to change. If the reciprocal of 1 over 2 gave us 2 over 1, which was just a 2. So what about -1 over 2? It's going to be a -2. So the reciprocal of this is going to be a -2. -2 over 1, which is just a -2. So we raise this to the exponent of -2, to the exponent of -2, to the exponent of -2, each and every term. So that if we multiply the original term to its inverse, remember the original number and its inverse gives us a 1. So that's x is equal to 5 to the exponent of -2. That's 1 over 25. This one, you can just use your calculator at that stage. Or x is equal to minus 4 to the exponent of -2, which is going to give us 1 over 16. But of these solutions that we are having, there's supposed to be only one solution there. There's supposed to be only one solution that we are supposed to consider in this equation, so that we obtain what? So that we obtain a 0. Take note, this on this equation that we had, all right, take note, there was a negative exponent there. So this is a negative, so it becomes a negative there, not a positive. All right, not a positive, but a negative, this one. So this cannot be a squared where we get a 25. This is going to be a negative, but we have to test our solutions. So let us just test our solutions in this case. The first one was 1 over 25. All right, so that's 1 over 25, like this, 1 over 25 to the exponent of what? To the exponent of a -1. Then this is minus x, which is 1 over 25. So that's 1 over a 25, like this. Everything to the exponent of what? -1 over 2 to the exponent of -1 over 2. So that's -1 over 2, like this. Then we're going to subtract a 20. In actual sense, remember, it was equal to 20 in the actual place. So if you do not subtract a 20, then it must give you a 20. But if you subtract a 20 like this, it must give you what? It must give you a 0. So let's see. This one, it gives us a 0 direct. So it means our x truly is supposed to be what? A 1/25. So this one, it is giving us the solution. What about 1/16? We change this, just put here 1/16 here. All right, that's just 1/16. All right, you do the same thing here, just 1/16, change this one into 1/16. So this gives us a -8, not a 0. So this one is not part of our solution. So therefore, in actual sense, our x is supposed to give us 1/25. So therefore, our x there is 1/25. This is the solution that we are exactly having from this. So be careful on this question. That was a negative here. A negative one. This is what we are having here, a negative, not a positive. If it was a positive, it was going to be another way we're going to get these solutions as 25 and 16. And 25 will be the solution. But that was what? A negative exponent. That's why our inverse is also a negative exponent. So you must be careful. So I want you to try the other questions as much as you can here so that you'll be able to see if we are moving on together. If there are any questions that I said, like I said before, which are still having a challenge, let me know so that we can work on those questions from these ones. We can try. There are so many questions there that you can put into practice as an individual.